started. Here we are. Welcome back, everyone. So we'll zip through the rest of this cloud services lecture, and then we'll have time for review afterward in a separate lecture session. So where we left off, we introduced Amazon, some of its basic cloud services, talked about how the cloud came around, why it's important, what made it necessary, all that sort of stuff. Okay, so where we left off was about here, talking about the core cloud attributes. So 5 essential attributes in any sort of viable modern cloud service: shared resources, elastic leasing, usage metering. It should be service-based and it should run over the internet. Okay, so go ahead and start with this. So shared resources. In order to achieve economies of scale, cloud providers have to be very, very, very large, much larger than their individual business clients. Because they have many different clients, they tend to have a smoother demand. That is to say, some businesses are busy at one time of the day, other businesses are busy at another. For example, if you're an operation that does most of its business through North America, you'll probably be busy during North America daytime hours. On the other hand, if your business is primarily operating out of Asia, then it's going to be busy during daytime hours in Asia. And the net effect will be that your demand will be fairly smooth throughout the day. If your demand is smooth, then it makes it a lot easier to plan for capacity, like how many servers you need to plan to have available at any given day, and longer term capacity upgrades. So if you're a big cloud service, you're going to be able to smooth your demand better than your smaller competitors. This is a reason why Amazon Web Services, it's the biggest of the public cloud services, why it can charge lower rates is because it has smoother demand. Okay. We talked about these: public cloud, private cloud, hybrid cloud. I'll do a quick recap. So public cloud, services open to anybody. You can also have what's called a virtual private cloud, where it acts like a private cloud. It acts like a private section of this public cloud. But a true private cloud means that the customer has exclusive use of those cloud service resources. That is, the network is devoted entirely to them. Now, in many cases, that means the organization itself owns the cloud, but they could outsource it to another service, and that service could build them a custom cloud network. And that is typically much more secure than a public cloud that is co-located on the same machines. Okay. Elastic leasing simply means users can change resource allocations at short notice. For example, if your normal business requires 10 servers on at any given time, but you know the next day you're going to run your Super Bowl ad and you expect a massive increase in your needs, you'd like to have that capacity available without having to jump through a whole lot of paperwork hoops for it. And then once the demand trails off, right, because you're going to get a lot of action at your website for the next couple of days, but then it'll gradually go back towards normal. You don't want to have to be on the hook for having all those extra services, all those extra servers available in a long-term contract. So with elastic leasing, businesses can pay for what they need when they need it, so they get an overall better value proposition. And if the cloud service is big enough, providing that sort of elastic leasing is not at all disruptive. Again, if you have a lot of clients with weekly correlated demand, then that means some are going to be busy while others aren't. And yeah, it's going to be fairly smooth throughout the day regardless. Okay. Now, in order to track how much of the cloud services businesses are using, you need to be able to meter it. You need to track what they're using. So again, businesses want to be able to pay for what they use. The cloud service charged a flat rate, that would overcharge some businesses and say, we don't want to be with them. They would find some other solution. On the other hand, excuse me, I'm about to sneeze here. The next question is different types of usage. For example, some cloud users might use a lot of storage space, but not much network capacity. Others might use a lot of CPU cycles, but not much storage space if they're running a lot of applications, but not storing much data. So there are all sorts of different ways that usage might be metered, right? They can be charged per server. For example, if the business is reserving a specific set number of servers in a virtual private cloud for a period of time, or it could be per unit of storage, right? Typically in gigabytes, or again, per gigabyte of virtual RAM that's being used. So whatever cloud services are being used, ideally the business gets to pay for what it's using when it uses them. Next thing, service-based. So service-based is a little bit difficult to explain. So this is the part where a lot of students have some trouble. What we mean by a service is essentially a modular application, typically a fairly small and simple one. And what businesses like to do, especially for cloud-based applications, is build their operations around these simple modular services. So let me give a quick example. I hope will make it have a little bit more sense. So imagine this. Imagine you're Amazon here, and you're doing some business with, I don't know, say Chase Bank. Okay, so here's Chase Bank, and down here, here's Amazon. Okay, and periodically they need to interact. Now, one positive for credit card processing credit card transactions, I'll make that. So Amazon processes credit card transactions through Chase Bank. Okay, so one possibility for that is simply that Amazon designs a custom interface. Right? They both communicate. There's some kind of custom interface here. Okay, that is one possibility. But if you have a custom interface, which I should add, uses a unique data format, that's basically what we need. They're sending data objects back and forth in some sort of unique format specific to this Amazon Chase Bank pair. Okay, that's what we mean by a custom interface. That means changes, right? If anything changes in what Amazon sends, data sends, and the data Amazon sends, let's phrase that better. Needs an interface update. Okay, if Amazon sends new data, it's going to require an update. Any changes in the data Chase needs requires an interface update. Okay, this is a bit of a problem because these things do change periodically, and updating the interface is a bit of a headache. The follow-up problem, what about all the other businesses that Amazon is doing business with, right? So I'm going to draw all these other interfaces here. So any of these other ones, whatever other financial operations Amazon is doing with. So other financial partnerships require their own interfaces. Okay, so this is not great. If the number of businesses involved is pretty small, sure, this is manageable, right? If you're only talking about 3 or 4 interfaces, sure, you can get by on that. That's not a big deal. But imagine if you're Amazon and you're doing business with literally millions of third-party services, right? Third-party operations that are selling things through Amazon. You don't want to have to design a custom interface for each of them. That would be a nightmare. And even if they individually don't change very often, the fact that you have literally millions of them means you're going to be doing a lot of work every day just keeping up with those interface changes. So what's better is something called service-oriented architecture. Okay, in that case, you design a standard interface. Okay, so I presented the problem. Now I'm going to present the solution. In service-oriented architecture, you build your operations around small modular applications called services. Okay. Importantly, these are standardized. So any financial operation would use the same service and would expect to use whatever data is in, right, is sent as a standard object. Okay, for example, a credit card transaction would typically include, number one, the credit card number, right, and expiration date and security code. Okay, all the credit card numbers. Number two, the items actually purchased. Okay, possibly for fraud analysis. Okay, the amount. That's pretty much it, right? So that's the stuff that you would send along. Now, Amazon doesn't need to know anything about how Chase or any other credit card provider actually uses the information, right? It just sends it along as an object. Here's the transaction. You give me a thumbs up or a thumbs down on it, right? Likewise, Chase or anyone else doesn't need to know the details of how Amazon will use the response, right? The yes or no response on whether the transaction goes through. So this enables a number of wonderful things. Let's resize this so I have a little more room. So I'm going to say positive consequences of service-oriented architecture, right? Service-oriented architecture would be, number one, a business can replace the workings of any module without affecting the interfaces, right? Basically, you can process the data differently, and that doesn't affect how either business is going to use that module. So that's a wonderful thing. Number two, business can actually switch out between modules or select from an array of options available to cloud users. Okay, so that's another option there. Even if you don't develop this yourself, if your business is already set up to use modular services that don't require knowing how Amazon does business and how Chase does business, then you can just go look around and see what's there at the cloud, and you don't have to design it yourself. Okay, those are the big, wonderful things. It just makes it, ultimately, service-oriented architecture makes your business applications tremendously flexible. It's easy to change them or include additional business partners. Okay, so I should add that as point three. Number three, business can reuse a module for any number. Some assholes calling up to tell me that I should update my car's credit. What's the thing that they call for? Oh, my long-term warranty, right? That's what I get, like, same as you guys probably. I get 10 calls a day about that shit. Anyway, business can reuse a module for any number of business partners. Okay, these are all wonderful things about service-oriented architecture. It's, as opposed to, again, if you decided to use a custom interface that looked at how Amazon arranged its data and needed to know how Chase did its data, yeah, you could potentially do more stuff with that sort of application, but it would be a bigger headache to design. Okay, so that's what we say here. Service-oriented architecture enables services can be located anywhere, right? You can select from any number of options available in multiple cloud services or options within a cloud. It's easier to modify them because as long as the interfaces don't change, as long as the data requirements don't change, it doesn't matter how the service itself works. and then you can reuse them, right? If you get more business partners doing the same thing, you can reuse an existing service over any of them. Okay, so what makes an application a service? Well, key things, all right? Number one, the application components are modular, right? That means they're self-contained little bubbles. All that the business needs to know is what the interface is, and it does the work. It's like putting something into a microwave, right? You don't need to know how the microwave works. You just put in the food and you operate the interface. You tell it how long it needs to run, and it'll do the work for you. Same kind of idea. Services also exchange data over networks and have standard input and output formats. Okay, web services, right? The follow-up to that, web services are methods for exchanging data in standard formats. So what we've talked about before is object description languages like XML or JSON, right? Those define particular object styles. So the example we had in the previous lecture was for an invoice that contained a bunch of items, right? You could present that as a standard object. If you're interested, have this very small, simple web service here is a conversion between Celsius and Fahrenheit temperatures, but I'm going to keep zipping ahead because we're a little short on time. Okay, so once an enterprise adopts service-oriented architecture and web services, that is exchanging information in standard formats, once that becomes its standard way of doing business, a lot of things become much easier, right? So number one, it can divide its applications into components. If its applications are already mostly set up as services, then those individual services can be deployed anywhere in the cloud. The cloud can have the freedom to deploy those application components wherever they're needed in order to make the whole system work better. Okay, all right. A couple other things. Migration. So the standard term for moving applications and data to the cloud is migration. And there's a few basic models on that. Number one is data only, right? You might keep all your applications running under your own roof, on premises or on-prem, as they say, but push your data to the cloud because there's too much of it and it's getting to be a big headache to access it. You need, you have so much data, you need a custom database to do it. So you push off your data that way. Another one is machine replication. So machine replication means making a copy of your existing system in the cloud. Basically, whatever kind of machines your system is running on, you try to replicate as far as possible which applications are running on which machines and where the data is stored. So you're just trying to build another copy of your system someplace else. The good thing about this is it's easy to test. The downside of it is, of course, you're probably going to end up buying more capacity than you need for the same reason that, businesses want to go to the cloud to save money. Well, you're not going to save as much money if you have to use the same number of actual physical machines as what you have under your own roof. The other option, what you might say the most idealized cloud option, is what's called physical to virtual. So in physical to virtual, you separate your applications into components so that they can be easily virtualized. That is to say, they can run anywhere, right? They're not tied to particular machines anymore. So that's a wonderful thing if you can do it. Downside is it requires a lot of testing. What often happens is you have assumptions built into your system at home that you're not fully cognizant of. For example, suppose your database design works pretty well under your own roof. And the reason it works pretty well is simply because it's not very big. And because it's not very big, tables are always able to be stored on one machine and you've never noticed that you have a problem with it. But imagine if your tables start getting big. They start getting big enough that they span multiple machines. And your code was never optimized to deal with this possibility that tables might be so large that they're going to span across multiple machines. But when you shift to the cloud, you start accumulating a lot of extra data because it seems there's no real cost in doing it. But eventually, your tables get large and suddenly you realize, wow, even in the cloud, all this stuff is taking a long time to run. So that's the sort of problem that can creep in if you haven't adequately tested your system. Okay. I should mention other issues. Once upon a time, it was a very big concern for organizations to somehow keep their systems running under their roof while they were migrating them to the cloud. Now it's less of an issue. There's various mechanisms For example, Amazon has one called Firehose that you can use to send all your data to the cloud at the same time as you're running it under your own roof. And eventually, when it all gets caught up, then you can just switch over to the cloud-based system. So they have a lot more tools designed to make that transition easier. Okay. Now there's three standard models for how cloud works: infrastructure as a service, platform as a service, and software as a service. Okay. Let's talk about the basic three things here. Okay. So infrastructure as a service, or IaaS, means you get the hardware, nothing else. Okay. So if you're buying that, that's what you get. Nice thing about infrastructure as a service, right? Maximum flexibility. You can do anything with it, but management headaches. Okay? You can do anything, thus it becomes a question of how good are you at doing it? How much trouble is it to do it? That sort of thing. Okay. Second one, which I'm going to build in a rectangle around it. Platform as a service. Okay, and platform as a service, or PaaS, you get infrastructure, right? So you get the hardware plus operating systems plus maybe some basic vanilla database apps. Okay. For example, if you go to Oracle, Oracle's a big database company. If you go to them and get on their platform as a service company, they'll give you some generic relational database software as well. Okay, but that's what you get. So platform as a service basically means just do it letters. Basically means the platform is set up for you to run your own custom applications. Okay? Less flexible than infrastructure as a service, but should be fewer headaches. You don't have to deal with the operating system side of it. That's already there for you. It's already all set up. Okay? Last one. Sure, let's do that in blue. Software as a service. Okay? And software as a service, basically, you get the platform plus pre-existing applications. And you don't have much choice, but you can choose settings and options and maybe some plugins. Okay, some extra features that you add on. But basically, the platform and applications are already there. You show up and use it, right? If you want a good example of software as a service, that would be Facebook. Okay, you just show up, log into Facebook, boom, all that stuff is there for uploading photos, for instant messaging, right? You can opt into instant messaging if you want or not. But the point is, all the applications are there. You're not going to really insert new applications into Facebook. Okay, so software as a service, easy to use. You just show up and start working. Okay, not much flexibility though. What's there is there. All right. Another example for software as a service would be G Suite, right? All the things that Google does, like Gmail, G Drive, all those other stuff. It's there. You show up and use them, but you're not going to insert new applications into that framework. Okay, so those are the three basic things. And in general, what you should expect to see Infrastructure as a service costs less than platform as a service, costs less than software as a service. Not always true, as you know, because things like Facebook and G Suite are, of course, free, but they're finding some sort of counterbalancing income streams on there, so you don't really pay for them up front. Okay, but obviously Facebook is making plenty of money, Google is making plenty of money, and their features are certainly part of that. Okay. So next few slides are just a recap of what I said. So infrastructure, again, you just get the hardware. In theory, but not always in practice, the cheapest cloud computing category, and you get maximum flexibility. You can install any operating system or applications you want, right? But the downside is you're responsible for everything, installing all this stuff, running them, doing updates, doing patches, all that. With platform as a service, you get a complete platform for deploying applications, right? You get the hardware, you get the operating system, and in some cases, you get some supporting applications. There's less control. You don't get the ability to put absolutely anything on it, right? You pick what operating system you want and you work with that. But the good thing is your IT people then have more focus. They can work on developing and deploying their own applications. They don't have really much control over the platform itself. Software as a service, again, you don't really have much control. The extent of the control you have is to opt in or out of using certain applications and changing settings on them. But again, what's there is there. But the nice thing is you just show up and use it. If you're not planning on developing your own custom applications, it's nice you can just go there and the tools that are there you can use, right? The only downside is what if your organization's needs change? You might have to go to a new operation. Okay, this last stretch, I'll talk a little bit about cloud vendors and then security. So, cloud services aren't terribly expensive of themselves, right? In general, businesses save money by going to the cloud, so it's not a question of whether they'll gain or lose, it's a question of how much they'll save in most cases. But it's difficult to make these decisions. For one, without directly experiencing the cloud service itself, it's difficult to make an informed judgment about how well it's going to work for your business. Other things like security policies and the technology that the cloud services use, those tend to be hidden as well. So again, tough to know exactly what you're getting. Ideally, there would be some sort of standard comparison thing, some comparison metrics, so you could look into the equivalent of like consumer reports for cloud services and say, oh, this is the service that definitely is going to meet our needs. But it's not quite that simple, right? You can talk to people that have been involved in cloud migrations, cloud vendor selection, and they'll tell you, well, we went with Amazon because it sounded good or the price was low, or they'll say we went with Azure because, you know, Joe, who were a similar thing, they'd used Azure and they said it was good. Azure is Microsoft's one. So, you know, this stuff is not as clear cut as you might think it should be. Anyway, the big cost models, usage-based and time-based. So in the usage-based model, you pay for what your applications are actually doing, how much data you're storing on the cloud system, how many CPU cycles your applications are running, how much data you're pushing through the network. And in a usage-based system, typically you're going to be sharing resources with other cloud users. Otherwise, you would go with a time-based system. In a time-based system, typically the resources are reserved specifically for you, but you pay for the length of time that you're using them. So if you reserve a specific number of servers and a specific number of hard drive equivalents, that's going to be what you're going to pay for. Okay, if you're interested, you can poke around through some of these real-world pricing options. They're surprisingly complicated. I'll just give you check out Amazon here. We'll see how this is. If we want to look at, say, compute, we'll go to EC2 just to start off the bat. First of all, they split it into on-demand and spot. So on-demand, it's there when you want it. You just show up and use it. Spot is a lot like flying standby. So if you have non-urgent application or data processing needs, you can put it on spot instances, and then Amazon will run it when some portion of the system is idle. So you don't get the fast response, but the work will get done and you'll pay less for it. So anyway, check out on-demand pricing. Boom, this is just for one thing, right, with Linux and on-demand pricing. Anyway, there's a long list of options, right? This is a lot of stuff. Okay, now of course, if this is all you do all day is pricing out different cloud options, you're going to get used to it pretty quickly, right? But for a lot of businesses, it's going to be their first time going to a cloud service, and they would be like, oh man, what do I do, right? So they'll have to find some outside consulting service perhaps to help them navigate through the option selection. Okay. So cloud service rates are often complicated even within a single provider. Across providers, you often get real apples to oranges comparisons, right? So basically, the services that Microsoft offers are similar but not exactly equivalent to the services Amazon offers. So in most cases, because the business is going to save money, whichever cloud service they go to, in most cases, it's better to consider cloud services in terms of fit. That is, what options are available, what services are available, and do they meet our current and expected future business needs, okay? And likewise, does it offer good performance for the typical range of usage of our applications? If you can answer yes to those, well, you're not going to be too far wrong. But what you don't want is to get fairly locked into one cloud service and then realize that there's some big important piece or two that it misses, and you're like, oh man, we can't keep using these guys, we got to switch over to this other one. That's a big hassle. Okay. Other measures of quality of service. So this is kind of like a wish list of things you would like to know about as a business. Things like accountability. Who owns the data? How compliant is the cloud service with good security practices? Things like that. Agility. So if there are new features available, how quickly are they implemented? And how sharp of a turn can I make in my usage, right? What's the elasticity? Is it easy to go from one server to 1,000? Is it easy to go from 100 servers to 10,000, right? Maybe there's a limit there that is important to a business. Cost is pretty straightforward, but businesses sure would like to know more about that. What kind of agreements are in place? So service level agreements are things, as you might, it's basically a contract that specifies what sort of services the business is going to get. For example, it might say something like the cloud service will be available 99.999% of the time. And if it's not available that often, right, if it goes down, has an extended outage, then the business can potentially get some compensation for that. Performance, again, fairly straightforward. What features are there? How fast do operations happen? Then security, right? Security is a big thing, of course. So businesses would like to know things like assessment results. Anytime the cloud goes through some internal or external security assessment, how well did it do? Historical results, right? Does it have a history of data breaches, for example? And then guarantees about privacy. So one of the issues with cloud services, businesses put data on the cloud, but it's not always a guarantee that that data gets erased when it should be. We'll talk more about that shortly. And last, how easy is the cloud system to use? How easy is it to get your applications and data migrated to the cloud? How easy is it to learn all the things the cloud can do? And how accessible are those data and applications? So all those usability features, right? That can vary a lot across users. If you're experienced with using the cloud, then what may seem very usable to you, it may still seem terribly scary to a relative cloud novice. Okay. Last thing, I believe, is the last slide. Yeah, cloud security. So we have first a few facts. So number one, cloud system security is on average better than most private information systems. But it's opaque. You don't get to know all the details about how the cloud system operates. So, yeah, historically speaking, there have been a lot more breaches into non-cloud systems than cloud ones. But it's also true, corporations are not invulnerable against security threats. There have been numerous cases where cloud services would get hacked in various ways, typically because of co-tenancy issues where multiple organizations had, or individual accounts had their data stored on the same server, and somehow one of the bad guys was able to, say, run a query that grabbed a bunch of data from that server, including stuff that wasn't theirs. So in general, if your business migrates stuff to the cloud, there's going to be a reduced risk of security problems, but the extent of the reduction is hard to predict in advance. There are, though, a few cloud-specific concerns. So number one, data leakage prevention. If you own your own network, typically, even if you can't see how the data is getting out, you're going to see that it is getting out. And even though you might not immediately make the decision to shut down all of your network, in the worst case scenario, that's a capability you have. On the other hand, if it's a cloud service and there is a data leak, right? How would you even know that there was a data leak until the cloud people figure it out? Well, you wouldn't. So you're kind of, at best, you're trusting them to tell you. Number two, talked about improper cloud configurations. So yeah, you can look up some details about that if you like. The iCloud hacks that happened about 10 years ago. Basically, there are ways where if people have access to the same machine, there are sometimes possibilities where one of the users could access data that doesn't belong to their account. Last one, deletion assurances, especially at the end of a contract. So imagine you've been working with a cloud service for 5 years, and at the end you decide, well, we're going to switch over to another one. You know, they have some features we like. So, you know, you say to Amazon, bye Amazon, we're switching over to Azure at the end of the month. And Amazon says, yeah, okay, no hard feelings. We'll make sure to delete all your data, you know, at the end of the month. And then you kind of stop for a second and you're like, well, wait, how do I know they're going to delete all my data? Well, the short answer is you kind of don't, right? Again, you kind of have to trust it. And that goes back into this accountability measure here. And I guess to a lesser extent, security. So, for example, you guys know about Snapchat, that the pictures are supposed to disappear shortly after they're sent. Well, they have found cases where some pictures were kept on servers as replicas, and for whatever reason, that hardware was not available when some copy of the data got wiped, and so those copies persisted for a while. Same thing could happen with any business and their data, right? It could be stored on a machine that somehow gets bypassed in the regular data clearing efforts and gets missed afterwards. So it's not a common thing, but yeah, it can happen. Okay. And that's the end. That's all I got. So I would stay and chit chat a little longer about this topic, but we do have a review session to do. So I'm going to cancel one. We're going to stop here. And then any questions you got, I'll see you shortly in the other lecture. All right. See you in a bit.